On November 19, 2025, NASA held a tense and highly anticipated press conference. The message was simple, direct, and confident. 3I Atlas is just a comet. Natural. Nothing more. But just 4 days later, across the country, another message was making waves, this time from Harvard University. Professor Avi Loeb, one of the most outspoken voices in modern astrophysics, dropped a bombshell. If we crunch the numbers, the chances that 3I Atlas is natural? Less than 1 in a trillion. One side is the world's most powerful space agency, with decades of missions, thousands of scientists, and some of the best telescopes ever built. The other? A scientist known for challenging the status quo, for asking uncomfortable questions, and for refusing to stay silent when the evidence feels too strange to ignore. So who's right? And more importantly, why does this debate matter so much for the future of humanity? Because this isn't just about a frozen rock from deep space. It's about how we decide what's possible and what's not in a universe we still barely understand. Before we dive into the evidence, before we go any further, I want to ask you something directly. What do you think is the real chance that intelligent life has already visited our solar system? 1%? 10%? Higher? Drop your number in the comments. Because today, you're not just watching a video. You're taking part in a mystery. And you just became part of the investigation. But before we dive into the deeper questions, let's rewind for a moment, because 3I Atlas isn't just some random object flying through space. It's the third known interstellar visitor to enter our solar system. And each one has been stranger than the last. The story begins in 2017 with Oumuamua, the very first object ever confirmed to have entered from outside our solar system. It was thin, fast, didn't behave like any asteroid or comet we've ever seen, and left scientists scratching their heads. That's also when Professor Avi Loeb first made headlines, by suggesting that maybe, just maybe, it wasn't natural at all. Then in 2019, a second visitor appeared, 2I/Borisov. This one looked exactly like what we expected, a classic comet full of gas, ice, and dust. It came and went, and most astronomers were relieved. Maybe the first one was just a fluke. But now, in 2025, comes the third 3I Atlas. And this one? It's bigger, faster, and weirder than either of the others. It arrived just as our observation tools reached their peak. We now have data from Hubble, Webb, HiRISE, Atlas, and more. Never before have we had this many eyes, this much detail, on an interstellar object. And yet, the mystery has only grown. Because 3I Atlas doesn't fit the mold. Its behavior, its chemistry, its motion through space, none of it adds up the way a normal comet should. And that's why this matters. If Avi Loeb is right, this could be the first confirmed detection of non-human technology, a probe or a vessel of some kind, launched by an intelligent civilization from somewhere far beyond our solar system. If NASA is right, this is a powerful reminder of something equally important, that science needs patience, skepticism, and solid evidence, not wild theories. Or maybe, just maybe, they're both right, in their own way. Maybe this object really is natural, but natural in a way we've never seen before. Either way, the stakes are enormous. Because the deeper we look into 3I Atlas, the more it forces us to ask, what else might be out there? And more importantly, are we even ready to know? So now that we understand the stakes, it's time to look at the evidence. Let's treat this like a courtroom. One side is presenting a bold theory, that 3I Atlas may not be natural at all, that it could be an alien probe. The other side says, this is just another comet, strange maybe, but still explainable. Let's begin with the case for the prosecution, Professor Avi Loeb's evidence. His argument isn't based on one single anomaly, but on a growing list of strange coincidences that, when stacked together, seem too precise to ignore. First, the smoking guns. Loeb's team discovered that the closest approach of 3I Atlas to the Sun, its perihelion, lines up almost perfectly with Jupiter's Hill radius. The odds of this happening by chance? About 0.00004%. That's 4 in 10 million. Now, why is that specific region important? Because in the 1960s, Carl Sagan and other astronomers proposed that if an alien civilization wanted to deploy long-term probes, Jupiter's Hill sphere would be the ideal place to do it. Stable, massive, and strategic. Coincidence? It gets stranger. The timing of 3I Atlas's path through the solar system allowed it to pass close to Venus, Mars, and Jupiter in sequence, almost like a planetary flyby mission. Loeb's team says this trajectory matches what a well-planned survey of inner planets would look like. And then, there's the anti-tail, a strange jet of material that seems to point forward, not backward like a comet tail. To some, it looks less like outgassing and more like a headlight beam, possibly even a directed energy jet. Let's move to the second tier. The wow signal. In 1977, a powerful, narrowband radio signal was detected by the Big Ear telescope in Ohio. It lasted 72 seconds, came from deep space, and has never been repeated. The source? The Sagittarius constellation. Now, in 2025, 3I Atlas enters the solar system from nearly the same direction, within 9 degrees. Loeb calculates the odds of it being a random overlap at 0.6%. No one's claiming it's a direct link, but still, the most mysterious radio signal in SETI history, and one of the most bizarre interstellar objects ever observed, both from the same region of the sky? It's enough to raise eyebrows. And finally, the third tier, chemistry. The chemistry mystery. Most comets contain 50% or more water ice. 3I Atlas? Only 4%. It also has a very high nickel-to-iron ratio, something Loeb says resembles industrial alloys more than natural space rocks. And as it approached the Sun, its brightness spiked rapidly, with a strange blue hue more typical of ionized gas or high-energy plasma, not dusty comet tails. Altogether, these oddities make a strong case that 3I Atlas doesn't behave like any comet we've seen before. But does that mean it's artificial? Let's hear the defense. NASA and mainstream planetary scientists argue that extraordinary claims need extraordinary evidence, and what we're seeing might just be nature being weird. Point 1. The duck test. If it looks like a comet, has a coma like a comet, a tail like a comet, and it's outgassing water, carbon dioxide, and carbon monoxide just like other comets, then why are we calling it a spaceship? Every major space observatory, from Hubble to JWST, reports a coma and tail consistent with typical comet activity. It walks like a comet. It quacks like a comet. Chances are, it's a comet. Point 2. Every comet is weird. Planetary scientists have a saying. Comets are like cats. They do whatever they want. Take Comet 17P/Holmes or C/2016 R2. Both had anti-tails, unusual chemistry, and sudden brightness changes. And that nickel-to-iron ratio? That could come from a comet forming in a colder, metal-rich region of interstellar space. It's unusual, but not unexplainable. Point 3. The math is flawed. Here's where it gets really interesting. Professor Jason Wright from Penn State criticized Loeb's statistical method. He called it a textbook example of post hoc probability fallacy. Imagine flipping a coin 10 times and getting this exact sequence. Heads, tails, heads, heads, tails, tails, heads, tails, heads, tails. The odds of getting that specific sequence? 1 in 1,024. But every sequence has that same probability. It's only after seeing it that we treat it like a pattern. The problem is, we're calculating the odds after the fact, which makes it meaningless. And that, critics say, is exactly what Loeb is doing. He's identifying rare events after observing them, then multiplying their probabilities as if they were independent. It looks dramatic, but it's not scientific. So who's right? Oddly enough, both sides agree on one thing. 3I Atlas is extremely unusual. The debate isn't about whether it's weird. It definitely is. The real question is, what kind of weird is it? Is this a natural object that challenges our models? Or is it something else entirely? And that's where the story really begins to turn. Now let's step back for a moment, not to look deeper into space, but to look inward. Because this isn't just a scientific debate. It's also a very human one. Let's start with Avi Loeb. It's easy to dismiss someone who challenges the mainstream as a fringe voice or a conspiracy theorist. But that's not Loeb. He's an accomplished astrophysicist, former chair of Harvard's astronomy department, a man who's published over 1,000 peer-reviewed papers. He's not chasing headlines. He's chasing possibilities. And he's not the first to do it. History is full of once dismissed ideas that turned out to be true. Continental drift, germ theory, the heliocentric model. All of them were radical until they weren't. Loeb's position is simple. Someone has to ask the uncomfortable questions, even if the answers never come, even if most people laugh first. But here's the important part: method matters. In science, how you conclude is just as important as the conclusion itself. So what about NASA? Why so cautious? Why so quick to label 3I Atlas as just another comet? The answer isn't arrogance, it's responsibility. NASA is the world's most visible science agency. If they speculate and get it wrong, they don't just risk embarrassment, they risk public trust, funding, political fallout. Alien talk doesn't just get headlines, it gets hearings in Congress. They've been burned before. They don't want it to happen again. And in many ways, that's the heart of this conflict. This isn't a battle between right and wrong, or science and science fiction. It's a tension between caution and boldness, between staying grounded and daring to wonder. And honestly, both sides have a point. So where do we go from here? Well, two key moments are coming, and they might change everything. First, December 19th, 2025. That's the day the full spectroscopic data is expected to drop. For months, telescopes around the world have been gathering light from the jets coming off 3I Atlas, breaking it down into a chemical fingerprint. And this is where things get decisive. If the object is natural, the spectrum will show familiar ingredients: water vapor, carbon monoxide, carbon dioxide, typical signs of cometary activity. But if it's something else, something engineered, then the signature could include unusual elemental ratios, traces of metals, or complex molecules that don't fit any known natural pattern. This is the kind of data scientists live for: clear, testable, conclusive. And then comes the next moment. March 16, 2026. That's when 3I Atlas is projected to pass near Jupiter's Lagrange points, the gravitationally balanced spots where objects can orbit indefinitely. And here's where Avi Loeb makes his boldest prediction yet. He believes that if 3I Atlas is truly a probe, it might release small satellites or devices into those regions. Silent observers. Long-term monitors. If that happens, it rewrites everything. But if nothing happens at all, no satellites, no signal, then Loeb's hypothesis could be dead in the water. One way or another, the timeline is ticking. But here's the truth: even if everything turns out to be natural, 3I Atlas has already done something extraordinary. It's forced us to ask questions we usually avoid. Questions like, are we truly alone? Would we even recognize alien technology if we saw it? And most of all, what kind of evidence would it take to change your mind? That's the real test. And it's one we all get to take, together. So now you've heard both sides. You've seen the data, the questions, the contradictions. You've explored the bold claims of Avi Loeb and the grounded skepticism of NASA and planetary scientists. But now it's your turn. Here's the challenge. If you believe Loeb might be right, explain this. Why does 3I Atlas show outgassing patterns just like a typical comet? Why would an alien probe mimic that behavior so closely? If you believe NASA has the stronger case, then tell us. How do you explain the anti-tail? The near-perfect match with Jupiter's Hill radius? Are those just random quirks, or signs we don't yet fully understand? And if you're still on the fence, what do you think would be the ultimate test? What kind of observation or experiment would finally tip the scale? Leave your thoughts in the comments. And if you make a strong, well-reasoned case, we'll pin the best argument at the top. But here's the most important thing I'll say in this entire video. Don't believe me. Don't believe Loeb. Don't blindly believe NASA either. Read the papers. Look at the raw data. Question everything. Challenge your assumptions. And make your own call. Because that, more than anything, is how real science works. It's not about choosing a side. It's about thinking critically, asking the right questions, and following the evidence wherever it leads. So go ahead. The floor is yours now. What do you think 3i Atlas really is? Part 7. Post-credits scene, crafted as a smooth and subtle 30-second Easter egg for voiceover, with tone, rhythm, and pacing carefully designed to close the video on a clever, mysterious note. Oh, and one more thing. There's one anomaly we didn't mention. The spectroscopic data drop? It's scheduled for December 19th. That just happens to be the birthday of Carl Sagan, the very person who first modeled the idea of interstellar probes parking inside Jupiter's Hill sphere. Coincidence? Maybe this time, it really is just a coincidence. Maybe,